23rd May GFG question. Dice throw. So we are given three arguments, m, n, and x. What is m? M is number of faces on a dice. Like it is given as 6, that is a standard dice. Then n is the number of dices. And x refers to the summation, target sum that we have to get. So basically what they are asking is that you have three dices, n number of dices, you have to throw them together. And when you throw them, what are the faces? There are 6 possible faces, like 1 to 6. It can have values 1 to 6 on top face. So you have to calculate the summation of the face that occurred on top, and you have to find the number of ways in which when you throw the sum becomes 12. So there are 25 ways. What are these 25 ways? Like suppose you start throwing dices and the first dice has a 1 on top face, the second dice has 5, and the third dice has 6. So you get 12 summation. Now you can also interchange the position, like second dice got 6 and the third dice got 5. Then also the summation is 12, and you can continue this if you want to. Like you can have 25 possible answers, possible positions, right? Now you can literally observe from the question that you have no other way than finding all possible number of ways, and whenever you have to find all possible ways, you go to backtracking, or even more, you go to DP, right? But if you still don't understand, you can always look at the constraints. The constraint here in the question are only till 50, and such low constraint are given only for DP, right? Now what is the approach here? So I usually prefer this approach. I mean, you can differ. I usually write the backtracking solution first, but it generally gets a TLE error. So if it is a correct backtracking solution, then only I start to think of the vector dependencies, like DP vector dependencies. What do you mean by that? Is that I determine then what is the vector here, 1D vector or 2D vector, or even if it is a 2D vector, here we have three parameters. So should we take m and n as our 2D vector? Should we take nx? Should we take xm? Like what should be our 2D vector? So then I write the DP memoization approach, right? So this is my approach of writing the DP solution, any DP solution. So let's first write the backtracking solution. So in the backtracking solution, we have to consider two things. That is the base condition and the number of recursion calls. Like what recursion calls do we make in that backtracking function? So if we can determine these two correctly, we can easily write our backtracking solution. So let's first look at the base condition. The base condition here is the number of dices. We can only throw 3 dices, and when we reach 3 count, we have to return back. So basically that's what I've written. I is initialized with 0, and whenever I becomes 3, right? So we will throw a dice when I is 0, we will throw a dice when I is 1, we will throw a dice when I is 2. So but it becomes 3, that means we have already thrown 3 dices, one at 0, one at 1, and one at 2. So that means that we have to stop, and if the summation is basically the current sum of the top faces of the dices that we have thrown. So if the summation is equal to the target sum, then we increment the count simply, and then we return back. And now we have to determine the number of calls. Now number of calls is basically number of faces. How? Because we are having 6 faces, so we can have anything from 1 to 6 on the top face of our dice. So we have to consider every case. So that is why we are looping from 1 to m, and we are basically incrementing I by 1 to move to the next dice, and we are adding the current top face value that is holding in j. So we added this to the sum. Sum is basically holding the sum of all the previous dices, the top faces of the previous dices, right? And these are normal arguments that are given in the question, and we are having a count variable. So this is a simple DP solution that works, but the only problem is that it gets TLE, right? It is correct solution, but it gets a TLE. So we have to further optimize it. Now, in order to optimize, what can we do? We can have a DP vector, of course. Now the DP vector, should it be 1D array or 2D array? How do you determine this? So generally, whenever you have to determine what are the dependencies in a DP vector, you can see what are the arguments that are changing when you are calling your backtracking function. So there are 2 arguments that we are having. One is I, and second is the summation argument. We don't have to deal with this m thing because it is already dealt in the loop, right? So basically you look at the arguments that you pass in your backtracking function. So these are generally the state variables of your DP. Like you can have a DP variable of what size n, y n, because I can be maximum n. It is starting from 0, it can be up to n. And another thing that you have is x. X is what? The summation, the target sum. But now you have to write x plus 1. Why x plus 1? Because summation is not starting from 0, right? If you have summation as 12, you have to access the index 12, and that's why you write x plus 1. So this is the dp vector, right? And this is how you generally determine the dependencies of a dp vector. Now you say that, okay, here there is a little problem. X plus 1 is the sum, right? So this is the target sum. This is not the sum that we can get in our backtracking function. Like if you call this, what is the worst possibility? That for all three dices, what can you do? You can have j as 6. So basically you can have sum as 18 at max. But the question is only for 12, right? Our array is only capable of storing till 12. So you do not call the backtracking function in case if your sum plus j is greater than your target sum, that is x. You do not call this backtracking function, otherwise you will get your segmentation fault or something like this, array index out of bound, this kind of errors, right? So this is the approach we're going to use. Let's look at the dp solution now. So I have done the same thing here. Okay, this is a backtracking solution. Let me get my dp solution, right? So this is also same. We have the same base condition. We basically return 1 or 0 based on sum is equal to x or not. This is a simple dp thing that we write in all dp questions, and we have to find the number of ways, right, for this current thing, right, current I and current sum. So for that, we that is the same loop, and this is the thing that I explained here, that sum plus j, if it is less than equal to x, only then we call this backtracking function, because otherwise our this x plus 1 will fail, right? We have to consider here x into n plus 1. If you don't want to write this condition, you have to use the space x into n plus 1, so that you can accommodate sum up to 18 or 19, basically sum up to 18. So that is why you need the size of array 19. So this will count the number of ways, and then you just basically assign, right? This is a simple dp solution that I can come up with. I still don't know that much about dp, right? So if you have any tips, or maybe if I'm doing something wrong, you can correct me, all right? Otherwise you can get this code in the github. So thank you.